Hello everyone, welcome back to CS with Andre, and today let's solve the problem number of ways to split array. So you're given a zero-indexed integer array nums of length n. The array contains a valid split at index I if the followings are true. The sum of the first I plus 1 element is greater or equal to the sum of the n minus I minus 1 elements, basically the sum of the remaining elements of the array. And the second condition is at least one element to the right of I, basically at least one element that forms like the right partition of the array. And basically we need to return the number of valid splits given these conditions. So this one seems more challenging than it is actually, but it gets easier if you draw it out. So let's go for this first example. So this is our array. Alright, so let's count how many possible splits can this array have. So starting from the left, we can take this possible partition. So the left side, the sum is 10. On the right side, the sum is 3, which means this works. Now we can try to move to the next one. The sum is 14, and the sum of the right side is minus 1, which works. And then the last one, because we need to have at least one element to the right, we have the sum as 6, and the sum here on the right is 7, which means we have two possible ways to split this. So as you could see, it was not as bad as it seems, counting how many possible ways we have going from left to right. So how do we do this by code? So basically, if we know the total sum of the array, we can find out, starting from the left, we can find the sum of the left side and the right side, going one index at a time. So we can go first check this index and see how much does it compare to the total, because the total lets us know how many we have on the left side. So if we go and say this is our possible portion and do a running sum down to the before last element and compare it to this sum and its difference with the total, we can find the right sum and the left sum at each given index. And then we can just count up every time the left sum and the right sum fulfill the condition, which means every time the left sum is greater or equal to the right sum. Alright, so here we are. So let me just outline to you what we're gonna do. So as I said, we're going to need the total, and then once we get the total, we're gonna do a running sum, which means for each valid index from the left, we're going to check if we have a valid split, which means if running sum, which is the left sum, is greater or equal to remaining, which is basically remaining right sum, which is basically total minus sum. And basically that's it. So just let's set up our variables here. I'm going to get a length, so the length of the array. Here I'm going to get the total, so just gonna do for each loop. So for each number in nums, total plus equals n. So now we get the total. Here, as I said, we're gonna do running sum. So I'm gonna do sum, which starts at 0. Actually, one thing that we need to make sure of is to check the constraints here, and as we can see, the values per index is relatively high. The maximum value is relatively high, so we need to make sure that we don't overflow. So instead of using integer here, I'm gonna turn this into long, so we have enough storage space to store the sum. And then I'm gonna have the count, which is what will return at the end here. So for each valid index, so while I starts from 0 and it ends right before the end of the array, so length -1. And here we're gonna add the sum, so nums I, and then we just check. So if sum is greater or equal to the total minus sum, which is if left is greater or equal to 0, then right. And if that's the case, just increase the count. And that's it. So this should work. Let's run this. As you can see, this is the most effective solution. Let's just evaluate our solution real quick. So since we just did a loop, basically 2 loops, 2 non-nested loops, we can safely assume that this is the time complexity is O of n, since we're just going through the values in one go. The space complexity is O of 1, as we just have a finite set, a determined set of variables each time that isn't affected by the size of the input. I hope it was easy to follow. Please leave any feedback and feel free to subscribe and leave a like. Thank you very much.